I need 8 units, 5 units, sugar fighting now. It just blew up. It just blew up. I need all 5 units to the sugar refinery now. It's on fire. It blew up.
At 7:15 p.m. on February 7th, 2008, a violent explosion erupted at the Imperial Sugar Refinery in Port Wentworth, Georgia, just outside Savannah. Surveillance cameras in the area captured the blast, which took the lives of 14 workers and injured 38 others. The Chemical Safety Board launched an investigation. The fuel for the blast? Combustible dust.
Combustible dust can be a catastrophic hazard in American industry. 3 of the 4 most serious accidents that we've investigated have been combustible dust explosions.
In 2006, this pattern of accidents spurred the CSB to issue a comprehensive study of combustible dust, which uncovered 281 fires and explosions that had occurred over the previous 25 years. The study revealed what the CSB called a significant industrial safety problem. Combustible dust fires and explosions continue to occur frequently, fueled by accumulations of combustible dust, which can gather over years in hidden places or in plain sight.
No company wants to see its facility blown up and destroyed and its employees killed, but they just don't understand what the hazard is. They don't realize that they have a hazard here until that one day when the explosion occurs, and it's a terrible tragedy for them. And they look back and say, if we'd only known.
When Tammy Miser got a phone call late one evening in 2003, she worried it would be about her brother, Sean Boone, who worked at an automotive parts factory.
And we usually didn't answer the phone that late, but we knew when it kept ringing that there was something wrong, so we answered it, and there had been an accident there before, so I knew. I knew if they were calling me, it was my brother.
Sean Boone was a mechanic at the Hayes Lemmers plant in Huntington, Indiana.
I got you going around the corner, man.
The company produced aluminum car wheels. The process of finishing the wheels left behind aluminum scraps, which were chopped into small pieces and sent to a furnace to be melted and reused. Chopping, drying, and blowing the dry chips through the transfer piping created highly combustible aluminum dust, which flowed through ducting to a steel drop box outside the building, where large particles were trapped. The air then entered a dust collector, which removed finer aluminum particles. Over time, aluminum dust accumulated inside ducts. In addition, there were leaks in the piping used to transfer aluminum chips, which caused dust to build up on surfaces throughout the furnace area. Aluminum dust landed on beams, ledges, and equipment. In some places, the dust was several inches deep. On the night of October 29th, about 10 minutes after workers started the aluminum chip melting process, aluminum dust inside the dust collector was suddenly ignited, perhaps by a metal ember or impact spark, resulting in a large explosion. The blast propagated back through the duct into the steel drop box, blowing it apart. The fireball and pressure wave continued back through the duct system into the building, gaining intensity as the accumulated aluminum dust ignited. The violent disturbance shook loose dust that had built up on external surfaces. At about 8:30 p.m., plant mechanic Sean Boone was one of several workers in the area of the furnace. Without warning, a fireball erupted from the furnace, engulfing the area and igniting airborne dust in a second, larger explosion. The explosion blew a 50-foot wide hole through the roof of the building. Co-workers found Sean Boone lying on the floor near the furnace, gravely injured. He was rushed to the hospital and put on life support.
And they told us that his internal organs were burnt, and they could take his arms, and they could take his legs, but he probably wouldn't make it, and it would just prolong it. So we went ahead and took him off.
Sean Boone was one of 14 dust explosion fatalities in 2003 alone. Launching a comprehensive investigation into the hazard, the CSB held 2 public meetings, convening panels of experts and listening to extensive public comment.
First, combustible dust is a real serious problem in all of general industry.
The CSB report concluded that good engineering and safety practices to prevent dust explosions have existed for decades, but there is no comprehensive federal standard requiring adherence to those practices. And many companies are not taking effective actions to control dust hazards. As a result, the board recommended increased regulation of dust hazards. The final report was approved at a public meeting in Washington in November 2006.
And the report and recommendations are adopted.
We found in our study that the issue of combustible dust explosions is not focused on one particular industry. It happens right across all industries, and industries that where you perhaps wouldn't expect there to be an explosion.
Industries at risk include food production, metal processing, wood products, chemical manufacturing, rubber and plastics, and coal-fired power plants. The CSB study provides many examples of the continuing toll from dust explosions. Coal dust exploded in 1999 at the Ford River Rouge plant near Dearborn, Michigan. 6 workers died and 36 were injured. Resin dust exploded at the Yan Foundry in Springfield, Massachusetts in 1999, killing 3 workers and injuring 9 others. Rubber dust exploded at Rouse Polymerics in Vicksburg, Mississippi in 2002, leaving 5 dead. A nylon fiber explosion destroyed Malden Mills in Methuen, Massachusetts in 1995. In fact, between 1980 and 2005, the CSB found at least 281 combustible dust fires and explosions that caused 119 deaths, 718 injuries, and major damage to industrial facilities.
NFPA supports...
Amy Beasley Spencer is a combustible dust expert at the National Fire Protection Association, or NFPA.
Beyond the loss of life and the injuries, when you think about the economic impact of a dust explosion, you hear about plants being completely destroyed. There's loss of jobs. It's an economic impact on the entire community.
The CSB report called on OSHA to establish a comprehensive regulatory standard designed to prevent dust explosions in general industry. The board said OSHA should base the new regulation on the current standards of the NFPA. These codes address hazard assessment, engineering controls, housekeeping, building design, explosion protection, operating procedures, and worker training.
The NFPA codes and standards have been in existence since the early 1920s, and there are 7 codes and standards that deal directly with dust. It's a tragedy to have even one loss of life because the technology is out there to prevent these dust explosions.
In addition to the NFPA, the Center for Chemical Process Safety, as well as a leading insurance company, have developed recommended practices on controlling combustible dust. The board also called for improved training of OSHA inspectors to recognize dust hazards. Interim CSB Executive William Wright explained the recommendation before the House Committee on Education and Labor in March 2008, citing 3 dust explosions the CSB had investigated in 2003.
State OSHA officers had inspected all 3 facilities prior to the accidents, but the dust hazards were never recognized or cited. Furthermore, the CSB determined that all 3 explosions could likely have been prevented if the facilities had implemented NFPA recommended practices.
In addition, the board recommended that OSHA revise its hazard communication standard to ensure that material safety data sheets better communicate dust hazards to workers. In response to the CSB's recommendations, in 2007, OSHA increased the enforcement of existing regulations through a new national emphasis program on combustible dust.
Without a comprehensive standard for combustible dust, it's difficult for businesses to know which specific NFPA provisions or other requirements they may be subjected to.
The explosions tragically continue. The list includes the blast that crippled the Imperial Sugar Refinery outside Savannah, Georgia, in February 2008.
Since 2005, about 70 additional dust explosions have been reported. And in fact, the Imperial accident last month is the deadliest industrial dust explosion in the United States since 1980.
CSB Chairman John Breslin.
I toured the facility about 6 weeks after the explosion. The damage that was done there was catastrophic. As you walk around the facility, you think of the people who were working there that day, who were killed and severely injured. It was a difficult experience to walk around that facility. It was a very sobering experience.
What is so frustrating about dust explosions is that they're so preventable. And I believe that one of the reasons that dust explosions continue to occur may simply be a lack of understanding about the materials. Most solid organic materials will explode if the particles are small enough and they're dispersed in a sufficient concentration. Some of the materials that could form combustible dust, and there are lots of them, could include coal, sawdust, food products like sugar and flour, pharmaceuticals, many chemicals, and even many metals.
Like all fires, a dust fire requires fuel, oxygen, and an ignition source. A dust explosion requires two additional elements: dispersion and confinement. The CSB commissioned laboratory tests using a sample of fine polyethylene dust found by investigators in the rubble of a North Carolina factory. Dust is dispersed into a flame, creating a fireball. When the dust is confined within a structure or a piece of equipment, a powerful explosion can occur and propagate, as this coal industry video demonstrates. Dust may accumulate on surfaces and lie undisturbed for years. Then some initial fire or explosion, known as a primary event, shakes it loose and ignites it.
It causes a pressure wave to go through the plant, and that dislodges all of the dust that is perhaps unknown up on the rafters, on the beams, on the tops of equipment, and that serves as the fuel for the secondary explosions that move through the plant.
Most of the fatalities and the devastating injuries have been caused by these secondary dust explosions.
According to the NFPA, a catastrophic explosion can occur from as little as 1/32nd of an inch of accumulated dust, around the thickness of a dime, covering just 5% of a room's surface area. The NFPA therefore recommends that companies control fugitive dust emissions, design facilities to prevent dust from migrating and accumulating, and perform rigorous housekeeping to remove any dust that does build up.
The NFPA codes have been adopted either at the state level or in some cases at the local level, at the city level. But the problem is they're not enforced in any regular way.
A catastrophic dust explosion at the West Pharmaceutical plant in Kinston, North Carolina in 2003 reveals what can happen when companies do not properly assess the hazards from combustible powders and do not design their buildings and equipment appropriately. West Pharmaceutical made small rubber medical products, such as syringe plungers and stoppers, at a large manufacturing facility with nearly 300 workers. In the process, large batches of rubber were compounded and rolled into long strips. To keep these strips from sticking together, they were dipped in a vat containing a whitish slurry of water and finely powdered polyethylene, a petroleum-based wax-like plastic. The coated rubber strips were then blown dry with fans and folded for later processing. As the rubber sheets dried, combustible polyethylene dust, which was not visible to workers but is colored white here for illustration, was blown into the air. Over the years, the air conditioning system drew polyethylene dust into the hidden space above an acoustic tile ceiling that was suspended over the production area. There, the dust gradually built up to a thickness of up to 1/2 inch on ceiling tiles, beams, conduits, and light fixtures, just a few feet over the heads of unsuspecting workers. January 29th began as a routine workday at the West plant. But at about 1:28 p.m., a small fire or explosion occurred somewhere near the production area. It lofted the accumulated dust above the ceiling into a thick cloud, which then ignited in a much more violent secondary explosion. Some employees described a sound like rolling thunder as the dust explosion spread throughout the space above the ceiling and ripped through the building. The accident at West Pharmaceutical Services took the lives of 6 employees and injured 38 others, including 2 firefighters.
The thing that set up the tragedy at West was the mere accumulation of hazardous dust above a ceiling.
The NFPA code says that any openings where a dust could accumulate must be sealed. The solution would have been to either seal it or to not have a suspended ceiling.
Another cause of the West accident was that workers were not informed of the dust explosion hazard arising from the polyethylene slurry, a fact that should have been included on the material safety data sheet.
At West Pharmaceutical, the dust wasn't well recognized as a hazard because it was actually in a slurry form. So the actual processing of the slurry, the drying of it, created the dust, and the dust migrated above the suspended ceiling.
Cleaning above the ceiling was overlooked in West's otherwise rigorous housekeeping program.
Cleanliness was a matter of pride for the West staff. Being in the pharmaceutical services industry, they kept the production area very, very clean. Some of them knew that large amounts of dust had accumulated above the suspended ceiling. Had they been aware that that was an explosive material, they could have informed management of the accumulation, and perhaps the situation could have been rectified before the explosion.
Jim Don is a leading expert on combustible dust.
If you got a dust, you need to know what the ability of that dust is to explode, and to be able to characterize that dust in terms of, does it take a little energy? Does it take a lot of energy to ignite it? Will this dust, when it explodes, create a very major overpressure? Those are the things that need to be onto a MSDS.
The CSB found that the problem of inadequate MSDSs is widespread. Of 140 MSDSs for combustible powders, the CSB found that very few included adequate dust explosion warnings or referred readers to the appropriate NFPA standards.
There needs to be better communication to workers on the issue of combustible dusts, and that should be done through improved information on material safety data sheets.
Less than a month after the West Pharmaceutical accident, a fatal dust explosion crippled the CTA acoustics plant in Corbin, Kentucky. The disaster at CTA, which claimed 7 lives, illustrates the critical importance of following NFPA recommended practices to control dust hazards. The CTA facility, with more than 500 personnel, produced fiberglass acoustic insulation for automobiles. Covering 300,000 square feet, it had 5 production lines. At line 405, fiberglass was fed along a conveyor system and spread to create a web. Black phenolic resin powder was deposited onto the fiberglass. Hundreds of thousands of pounds of the combustible resin powder were used in the plant every month. Next, the mat former used air suction to spread the resin through the fiberglass. Excess powder and fibers were drawn up into a dust collector and rapidly accumulated on long cloth bags. After the mat former, a nylon facing was rolled onto the fiberglass before it entered a gas-heated curing oven. Combustible resin accumulated in the oven, resulting in frequent small fires that were extinguished by workers. During each shift, the line was shut down for cleaning. On the roof, employees routinely used compressed air to dislodge dust that had built up in the ductwork. dumping the material into a large open box on the production floor. On the production line, workers also used compressed air to blow dust off equipment. They swept the production floor with brooms. These cleaning activities created dust clouds so dense that large fans were used to blow the dust away from the operators. This increased the dispersion of dust in the plant. The dust settled on horizontal surfaces throughout the entire production area. Over years of operation, dust built up on top of pipes, electrical conduits, and other hard-to-clean elevated surfaces such as roof trusses. A pile of resin dust more than a foot deep had built up on top of the blend room due to periodic cleaning of clogged equipment. On the morning of February 20th, 2003, production line 405 was shut down for routine cleaning. The oven was still on, with one of its doors left open to control the temperature because the oven thermostat had broken weeks earlier. CSB investigators later determined that most likely a small fire, unseen by workers, had started inside the oven, fueled by a buildup of combustible resin. During cleaning, workers had discovered that a transition duct leading from the mat former to the dust collector was clogged. They used a compressed air lance to dislodge the material back through cleanout doors into the production area. Together with other cleaning activities, this created a dense dust cloud around line 405. A wall fan blew the cloud toward the open oven. The dust was ignited by the small fire inside. Flames erupted from the oven, igniting the larger dust cloud, which exploded. This was quickly followed by a second dust explosion at the other end of the production line. 4 employees nearby were injured. 1 later died from severe burns. The force of the 2 explosions shook the building and dispersed accumulated dust throughout the production area. This airborne dust fueled a quickly moving fireball, spreading west along the roof trusses toward production line 403, which was also surrounded by dust. 4 workers in this area were fatally burned. The fireball continued past line 402, fatally injuring 2 more workers, and then to line 401, where a third explosion occurred nearly 300 feet from where the first blast was ignited. 3 workers in this area were severely burned.
The 4 production lines were not adequately segregated, and this allowed the dust explosion to very quickly travel from one production line to the next. And in this case, most of the employees who died were actually working a far distance from where the initial fire began.
NFPA recommends minimizing horizontal surfaces where dust can collect. But the CSB found that this was not done at CTA.
At CTA Acoustics, there were many actions that were being completed that were prohibited in the NFPA codes and standards. For instance, if you're using compressed air, that can create more dust in the air to cause a larger fuel load for the actual explosion.
CTA personnel also used brooms and fans to clean the production lines, which dispersed dust throughout the building. NFPA standards emphasize the use of safe cleaning methods, such as vacuuming with specialized equipment.
Well, in normal, routine, daily housekeeping, workers address the working and walking surfaces in their production areas. They address their equipment, the places that they can see. But when it comes to preventing dust explosions, much more is needed. You have to clean in the out-of-the-way places, up near the rafters.
You also don't want to over-rely on housekeeping, because if you have housekeeping round the clock and you're still seeing layers of dust, you might want to look at your system to see why that dust is being produced in the first place.
The CSB also found the material safety data sheets for the phenolic resin powder used at CTA did not adequately warn of the dust explosion hazard. Kentucky State Fire Inspectors had not visited the facility since its construction in 1972. Insurance companies had inspected the plant on multiple occasions, but never identified the dust hazard. Neither had state authorities.
We found that Kentucky OSHA had, in fact, inspected this facility not long before the explosion, yet they had not uncovered the combustible dust hazard. We further learned that they had not received specific training to be able to detect this deadly hazard.
Following the CSB investigation, Kentucky officials established a new program to inspect facilities with dust hazards and developed an educational bulletin on dust, which was distributed to thousands of facilities.
There's been a big explosion here. What's happening?
Why do these accidents keep occurring is the age-old question. The knowledge is out there to make sure that no deaths occur due to dust explosions.
I think the big problem with combustible dust is that we underestimate its hazards. We become complacent and we fail to take the necessary precautions.
But it's not going to happen in my plant. Because it never happened that way before. I mean, we've been operating for 40 years and never had a problem. That kind of a logic is one that can guarantee you get into trouble. Any material that they have in their process in a dust form should be tested to determine if it is a dust explosion potential or not.
In the 1970s and 80s, the U.S. experienced a series of grain dust explosions that killed many people. OSHA responded with new regulations in 1987 requiring preventive maintenance, worker training, and formal dust cleaning programs in grain handling facilities. A 2003 OSHA analysis concluded that the number of deaths from grain dust explosions had dropped dramatically.
OSHA has a specific standard for grain dust, and that's been a very successful standard, and it has significantly reduced the number of accidents involving grain dust.
I believe if there were a national OSHA requirement dealing with dust explosions, that the incidence would be significantly decreased.
In April 2009, Secretary of Labor Hilda Solis announced plans for a comprehensive regulatory standard.
Where workers are in danger, where mandatory regulations make sense, we will act and we will implement. And I'm announcing today that OSHA will begin the rulemaking on combustible dust.
What I feel that we need to do to prevent combustible dust explosions is threefold. We need education, we need industry to understand what the hazards are. We need regulation, we need a comprehensive combustible dust regulation, and we need enforcement of the regulation. And I feel if we do all three, we'll go a long way to preventing these terrible tragedies that we're seeing with combustible dust explosions.
The only way that, to keep my brother from dying in vain would be to make changes. And if there's not a change made, well, then you know it's going to happen again.
I hope that people who watch this video will take the lesson that they really need to do something to prevent combustible dust explosions.
For more information on combustible dust, please visit csb.gov.